Assalamualaikum and hi everyone. Jadi sesi kali ini kita akan lihat presentation para pelajar yang akan berkongsi ilmu bersama kawan-kawan bagi persediaan menghadapi final exam yang bakal tiba dalam sesi dari kita untuk kita. Jom kita tengok.
Hello, me Najma Sarah with Nurul Habibah will teach you momentum and impulse. Without further ado, let's go. So the first thing we should learn is define the momentum and impulse. So, momentum. Momentum is defined as the product of mass and velocity. The formula for momentum is mass multiplied velocity. The SI unit for momentum is kilogram meter per second or Newton second. It was a vector quantity. The direction of momentum is the same as the direction of velocity. If the velocity of the object is zero, then there are no momentum. Impulse. Impulse can be defined as the product of force and the time interval. Formula for impulse is force multiplied with time. Impulse also equals to change in momentum, which is momentum final minus momentum inertial. Therefore, force multiplied with time equal to change in momentum. Unit SI for impulse is same as momentum, which is Newton second or kilogram meter per second. Impulse is a vector quantity. The direction of impulse is the same as direction of force. Impulse also can be determined by using graph of force against time. As you can see, we can find impulse at shaded area under the graph of force against time. Impulse momentum theorem. Impulse momentum theorem states that the impulse of the force equals to change in momentum of the body. As I stated before, impulse equal to change in momentum, which is momentum final minus momentum inertial. Also can be written as mass multiplied with velocity final minus mass multiplied with velocity inertial. You may ask why this happened. It is because you need to remember that momentum is equals to mass multiplied with velocity. So that's why change in momentum is equals to mass multiplied with velocity final minus mass multiplied with velocity inertial.
Next, we're going to look for the example question of our second learning outcome, which is solve problem related to impulse and impulse momentum theorem. Now look at the first question. A 1,600 kg car starts from rest and accelerates at 2.5 meters squared. Calculate the car's momentum after 15.0 seconds. To make it more clearer, extract the information from the question. The question asks for momentum. Formula of momentum is P equals to mv. So, we must find the v first. By using equation v equals to u plus at, substitute the equation with u equals to 0, acceleration 2.5 meters squared and time 15.0 seconds. Then we get the answer, which is v equals to 37.5 meter per second. To calculate momentum, use formula P equals to mv and substitute the m given and v that we count. Hence, the final momentum is 60 exponent 3 kg meter per second. Next, continue for example 2. I draw a diagram from the equation given. We can see that an electron with mass 9.1 exponent negative 31 kg with velocity 9.8 exponent 6 meter per second hit the metal target and rebound with velocity 7.5 exponent 4 meter per second. Do not forget to add the negative sign to v final because velocity is a vector quantity that considers the direction. Question A asks for initial and final momentum. We assume that u equals to v initial and v equals to v final. Substitute in formula of momentum and then we get the answer for initial momentum and final momentum. Question B asks for the impulse. As we know, impulse also equals to change in momentum. Change in momentum means momentum final minus momentum initial. As we already calculate the final momentum and initial momentum, we substitute into the equation and we get the answer, which is negative 8.99 exponent negative 24 kg meter per second. As you can see, the answer is negative, so the direction of impulse is opposite to the initial motion of the electron. Question C asks for average force. The formula of average force is delta P over delta T. Substitute delta P, which is the change of momentum, and delta T is given in the question. So we get the answer, which is negative 1.80 exponent negative 18 Newton. Next example is related to our third learning outcome, which use F against T graph to determine momentum and impulse. The equation shows a graph that belongs to an object with mass 2 kg and the velocity or the initial velocity is 10 meter per second that move on a horizontal surface, and if a force is applied to this object between 1 to 7 seconds, the equation asks the velocity of the object at 7 seconds. Before that, we know that impulse can be found by calculating the area under the graph of F against T graph. To calculate the area under the graph, the area is divided into 4 areas. For A1 is a triangle, so half times 1 times 6 equals to 3. A2, 3 minus 1 times 6 equals to 12. For A3, a triangle, half times 5 minus 3 times 6 equals to 6. And for A4, it's a triangle, so half times 7 minus 5 times negative 2 equals to negative 2. So since 4 is the vector quantity, so it's considered the direction. Total of the area under the graph, which is A1 plus A2 plus A3 and plus A4, so that we get the impulse, which is 19 Newton second. Since the question asks for velocity, we use the formula impulse equals to change of momentum, or momentum final minus momentum initial, also equals to mv minus mu. Substitute the impulse that we calculate, method given, and u the initial velocity, the answer, which is velocity equals to 19.5 meter per second.
This is the summary for T.1 momentum and impulse. You can use this as your short note or revision before the final exam. So, good luck!
Okay, Assalamualaikum warahmatullahi wabarakatuh. Hi guys, okay, nama saya Nur Indah binti Tahir dari S15P6. Okay, this video saya akan bentangkan chapter 3.2 iaitu Conservation of Linear Momentum. Okay, first thing yang kita semua kena tahu ialah benda ni kena hafal tau. So, total linear momentum is zero or constant if no external force acts on a closed system. So, berdasarkan principle, kita tahu in a closed system, total F net kita is equal to 0. So, total of initial momentum is equal to total of final momentum. Okay, next. We have two types of collisions, which is elastic collision and inelastic collisions. Okay, macam mana nak kenal? Kalau elastic collision, after the collision, the object will move separately. So, okay, this ball A akan hits another ball B. So, after the collisions, A and B will move separately. A akan bergerak ke kiri dan B akan bergerak ke kanan. Okay, inelastic pula, after the collision, the object will stick or move together at the same direction. Okay, so before the collision, A akan bertembung dengan B. So, after, kita akan dapati ada dua situation. Sama ada dia akan stick together ataupun dia tak stick tapi dia still akan bergerak in the same direction. Okay. This is the similarity and difference between elastic collisions and inelastic collision. Okay. Persamaan both collision ini ialah kedua-dua collision is total momentum is conserved. So, bila total momentum is conserved, our total P initial is equal with total P final. But the difference between elastic collision and inelastic collision is, kalau elastic, total kinetic energy is conserved. Maksudnya, our total kinetic energy initial is equal with total kinetic energy final. Tapi kalau inelastic pula, total kinetic energy is not conserved. So, our total kinetic energy initial is not equal with total kinetic energy final. So, okay, macam mana kita boleh dapat tahu type of collision sama ada dia elastic or inelastic melalui total kinetic energy. So, kita boleh kira kalau total kinetic energy initial is equal dengan total kinetic energy final, maksudnya dia elastic. Kalau not equal, dia inelastic. Okay, we move to the next part. Okay, hari ni video ni saya akan terangkan tentang linear momentum in one dimension collisions. So, the next video kawan saya akan terangkan tentang two dimension collision pula. Okay. Example 1. A 6.25 kg ball moving with velocity 5.5 ms hits a 1.2 kg ball in rest. After the collision, the balls stick together and move with constant velocity. Calculate velocity after the collision. Okay, we have one ball here with mass 6.25 kg. Initial velocity 5.5 ms. Okay, dia bergerak dan hits another ball with mass 1.2 kg in rest. Bila dia kata in rest, maksudnya dia tak ada velocity. So, initial velocity is equal to 0. After the collision, the balls stick together and move with constant velocity. So, bila dia kata stick together ni, kita dah boleh tahu yang ianya ialah inelastic collision. Okay. After the collision, the ball stick together here and V apa yang kita nak cari lah. So, kita tahu elastic dan inelastic collisions, the total momentum is conserved. So, kita guna formula total P initial is equal with total P final. So, M1 U1 plus M2 U2 is equal with M1 V1 plus M2 V2. Okay, so kita masuk je kan nilai yang kita dah senaraikan tadi. Okay, kalau nak senang lah, bila kita baca je soalan, kita terus lukis gambar aja, kita terus keluarkan maklumat. So, kita tak adalah careless, kita senang nak faham kan. Okay, so masuk je kan kita punya nilai dan dapat V is equal to 4.6 ms. Okay. Soalan B. The total loss of kinetic energy. Okay, kita pun tahu soalan ni tentang inelastic collision. So, inelastic collision, the total kinetic energy is not conserved. Maksudnya, total kinetic energy initial is not equal with total kinetic energy final. So, there is a total loss of kinetic energy here. Okay, first we need to okay, kita senaraikan maklumat yang kita cari termasuk V tadi iaitu 4.6. Okay, first kita kira, sebenarnya boleh je kira dalam satu satu benda ni, tapi I suka keluarkan sebab lebih mudah kan. Okay, first we need to calculate the total kinetic energy initial. Masuk je kan dalam formula 1 per 2 M1 U1 squared plus 1 per 2 M2 U2 squared. So, masukkan nilai yang kita dah dapat ni, dapat 9.3 93.775 Joule. Lepas tu kita akan kita cari pula total kinetic energy final 1/2 m1 v1 squared plus 1/2 m2 v2 squared. Okey, disebabkan total kinetic energy final ni V dia sama kan, so kita derive balik supaya lebih mudah. So V ni saya keluarkan, so 1/2 masukkan nilai, dapat 78.292 Joule. So the total loss of energy is total kinetic energy initial tolak total kinetic energy final. So bila kita tolak, kita dapatlah jawapan 15.48 Joule. Joule. Unit jangan lupa. Okay, example 2. A bullet fired from a pistol has mass of 8.0 gram and a muzzle speed of 352 ms. If the mass of the gun is 0.9 kg, what is its recoil speed when fired horizontally? Okay, we have one pistol here, one gun. One gun, actually, it's gun. Okay, sama je sebenarnya. Okay, bila kita ada gun here and a bullet in a gun, dalam gun ni, dalam pistol ni. So, our mass of bullet is 8 times 10 power of negative 3 kg. Kita tukarkan kepada kg. So, mass of gun is equal to 0.9 kilogram. So our initial velocity is of bullets is equal to initial velocity of gun is equal to 0. Why? Sebab dia masih dalam keadaan rest. Dia belum tarik picu. Dia belum ditembak lagi. Okay, so ni ialah before. Okay, after pula bila kita dah tarik picu ni, okay, peluru dah keluar. Bila peluru keluar, peluru tu akan bergerak ke hadapan kan. Okay, pistol pula akan bergerak ke belakang. So kita dapati kat sini dia akan moving separately kan. So kita dapat tahulah yang ni adalah elastic collision. So saya letak kat sini adalah velocity bullets, yang ni velocity of guns, V, velocity final dia lah. So dia dah bagi VB is equal to 352 ms. So this is elastic collisions. So we know that total momentum is conserved. So total P initial is equal to total P final. So macam tadi kita masukkan je dalam formula. So yang ni akan dapat kosong sebab U dia kosong. Dan akhir sekali kita akan dapat VB is equal to negative 3.13. Kenapa ada negatif? Sebab dia bergerak ke belakang lah kan. Memang kita akan dapat negatif. Okay, tu saja. Terima kasih.
Hi, Assalamualaikum. My name is Nurahi binti Mami. I'm from S15PC. Today, I'm going to discuss with you guys about conservation of linear momentum in two-dimension collision. Before we jump to the question, we're going to learn the differences between one-dimension collision and two-dimension collision. For one-dimension collision, if two objects make a head-on collision, they can bounce and move along the same direction they approach from. This is for a single dimension. If the objects stick together after the collision, the equation will be m1u1 plus m2u2 is equal to m1 plus m2 times with v. In here, the velocity of 1 is equal to velocity 2 is equal to velocity. The velocity is the same because they move in the same direction. For two-dimension elastic collision, if two objects make a glancing collision, they will move off in two dimensions after the collision, like a glancing collision between two billiard balls. For a collision where objects will be moving in two dimensions, for example x, y, the momentum will be conserved in each direction independently, as long as there is no external impulse in that direction. In other words, the total momentum in the x direction will be the same before and after the collision. Also, the total momentum in the y direction will be the same before and after the collision. So, let's say if we have a 5 kg ball and it's moving east with a speed of 6 meters per second, and it strikes a 3 kg ball that is initially at rest. Now, after the collision, the 3 kg ball is going to this direction at an angle 60 degrees with respect to the horizontal, and the 5 kg ball after the collision is going to 30 degrees below the x-axis. So, with the information, how can we calculate the final speed of 5 kg ball and 3 kg ball? So, as we know that the total momentum of initial is equal to total momentum of final in x direction. So, the equation will be m1u1x plus m2u2x equal m1v1x plus m2v2x. m1 here is 5 kg, u1x is 6 meters per second. M2u2x is 0 because the second ball is at rest, so the value will be 0. M1 is 5 kg, V1x is V1 cos negative 30. Why negative 30? Because it is below x-axis. Plus, M2 is 3 kg, V2x is V2 cos 60. 5 times 6 is 30, equal 5 times cos negative 30 is 4.33 V1, plus 3 times cos 60 is 1.5 V2. Now we're going to move to the y direction. As we know that the total momentum of initial is equal to total momentum of final in y direction. So the equation will be m1u1y plus m2u2y equal m1v1y plus m2v2y. Initial momentum is 0 because there is no y component. So we're going to move to the final. M1 is 5 kg. V1y is V1 sin negative 30. Why negative 30? Because it is below x-axis. Plus, M2 is 3 kg. V2y is V2 sin 60. So, 0 is equal to negative 2.5 V1 because 5 times sin negative 30 is negative 2.5 V1 plus 3 times sin 60 is 2.5981 V2. So, we move the negative value to the left. So, jadinya 2.5 V1 sama dengan 2.5981 V2. So, kita bahagikan 2.5 dengan 2.5981. So, jadinya 0.9622 V1 is equal to V2. So, sekarang ni kita dah dapat nilai V2 tapi dia belum selesai sebab ada V1. Kita kena masukkan nilai V2 ini ke dalam equation yang pertama, iaitu 30 equal 4.33 V1 plus 1.5 V2. V2 kita dapat tadi, so masukkan je 0.9622 V1. So dapat 5.7733 V1 equal 30. Kita dividekan, jadinya V1 dapat 5.196 meter per second. Now, kita dah dapat V1, dia nak V2 pula. So, kita masukkan balik dalam equation yang kedua. So, V2 sama dengan 0.9622 times with V1. V1 is 5.196 meter per second. So, V2 is 5 meter per second. That's all. It's so easy, you can invest into it. Now, let's move to the question 2. Two cars A and B that initially moving in opposite direction to each other. The cars then collide with each other and bounce off. The mass of the car A and B are 1,500 kg and 2,000 kg respectively. The initial velocity of car A and B are 25 meter per second and 20 meter per second respectively. And the final velocity of car A is 4.2 meter per second with angle 10 degree. If there is no change in the car mass, calculate the final velocity of car B in SI unit and sketch its direction after the collision. So, kita keluarkan data dulu. Dia bagi kat sini, mass car A equal 1,500 kg, initial velocity KA pun dia bagi 25 meter per second. Dan final velocity KA pun dia bagi juga 4.2 meter per second. Angle KA dia bagi 10 degree. Mass KB dia ialah 2,000 kg. And the initial velocity KB is 20 meter per second. Sekarang dia tak bagi final velocity KB. Kita kena carilah. And then sketch direction after the collision. So, melalui information yang kita dapat daripada question, kita boleh buat direction untuk KA. Sebab KA ni, dia dah bagi complete information. KA ni adalah the bounce off after collision kan. So, kita boleh buat direction dia, di mana dia punya velocity, final velocity dia adalah 4.2 meter per second. And angle pun dia dah bagi 10 degree. Kita boleh buat dia punya VAX sama dengan negative 4.2 cos 10 degree. Kenapa negatif? Sebab dia ke arah negative X direction. And then VAY dia sama dengan 4.2 sin 10 degree. Okay, dekat sini korang kena tahu, kita tak ada, semasa before collision, kita tak ada Y component. Kita hanya ada X component. Kita punya soalan nak apa? Final velocity of KB and sketch its direction after collision. The total momentum of initial is equal to total momentum of final in X direction. So the equation will be MAUX plus MBUPX equal MAVAX plus MBVBX. MA ialah 1500, UX dia ialah 25, tambah MB dia ialah 2000. UBX dia adalah negatif 20. Kenapa negatif? Sebab KB dia bergerak dalam negative X direction. Equal MA ialah 1500, VAX dia ialah negatif 4.2 cos 10 degree, plus MB dia ialah 2000, VBX dia kita nak cari. And then kita dapat negatif 2500 sama dengan negatif 6204.289 plus 2000 VBX. And then kita pindahkan dapat 3704.29 equal 2000 VBX. And then kita dividekan, dapat VBX sama dengan 1.85 meter per second. Now we move to the Y direction. So the total momentum of initial is equal to total momentum of final in Y direction. The total momentum of initial is equal to 0. Kenapa? Sebab there is no Y component. Now we move to the final. MA ialah 1500, VAY ialah 4.2 sin 10 degree, plus MB ialah 2000, VBY kita nak cari. And then, kita dapat VBY sama dengan negative 0.55 meter per second. And then, kita nak cari velocity of KB. Kita guna formula VBX kita kuasa 2 kan, tambah VBY kita kuasa 2 juga. And then, kita punca kuasa 2. Dapatlah VB 1.93 meter per second. And then, kita dah dapat velocity of KB. Kita kena cari angle dia untuk sketch tu punya direction after collision. So, kita buat theta is equal to shift tangent darab dengan VBY bahagi dengan VBX. So, kita punya theta kita dapat 16.56 degree. Selepas kita dah dapat semua data ni, kita boleh sketch tu punya direction after the collision. So, kita punya VBX kita adalah 1.85 meter per second. So, kita punya VBY kita adalah negatif. That's why kita punya sketch ni, VBY dia ke bawah sebab dia negatif 0.55 meter per second. And then yang punya VB ni dekat tengah ialah 1.93 meter per second and the angle is 16.56 degree. So, the final question that we're going to do here is question 3. The two balls shown in figure below collide and bounce off each other as shown. What is the final velocity of the 500 gram ball if the 800 gram ball has a speed of 15 cm per second after the collision? So, before kita move dekat dia punya solution, kita kena keluarkan data dia dulu. Mass A dia bagi 800 gram kan? Tapi dekat sini saya tukarkan kepada kilogram untuk memudahkan. So, mass A ialah 0.8 kg. Initial velocity A dia bagi 30 cm per second. Kita akan tukarkan kepada meter per second. Final velocity A ialah 0.15 meter per second. Mass P ialah 0.5 kg. Initial velocity V is 0.5 meter per second. Now, kita kena find the velocity V after the collision. So, kita boleh buat kita punya direction after collision for pole A. Dia punya VA dia bagi 0.15 meter per second. VAX kita boleh cari juga 0.15 cos negative 30. Kenapa negative 30? Because the angle is below x-axis. So, the VAY is negative 0.15 sin negative 30. The total momentum of initial is equal to the total momentum of final in x direction. So, the equation will be MAUX plus MBUBX equal MAVAX plus MBVBX. MA ialah 0.8, UX ialah 0.3 plus MB is 0.5, UBX is negative 0.5. Kenapa negative? Sebab ball B is moving at negative x direction. Equal 0.8, VAX is 0.15 cos negative 30 plus MB is 0.5, VBX kita nak cari. And then kita dapat VBX ialah negative 0.2278. Now we move to the y direction. So the total momentum of initial is equal to total momentum of final in y direction. The total momentum of initial is equal to 0. Why? Because there is no y component. MA is 0.8, VAY is negative 0.15 sin negative 30 plus MB is 0.5. VBY kita nak cari. And then VBY kita dapat negative 0.12 meter per second. Now kita nak cari velocity of ball B. So kita guna formula VBX kita kuasa 2 kan, tambah VBY kita kuasa 2 kan, and then kita square root. VB kita dapat 0.26 meter per second. Now kita nak cari dia punya angle. So theta is equal to shift tangent times with VBY divided by VBX. So kita dapat angle dia 27.78 degree. I think that's all from me. Thank you for watching. I hope this video will help you guys. Good luck for PSPM. Bye bye.